From your study of natural languages, you know that pretty much every language can be broken down into pieces, and there are certain rules for how you put pieces together. Programming languages are no different, and in fact they are far stricter about the rules. And in this video we're going to talk about some of the basic rules for Scala. So if we go into Scala, turns out that, so for example in English, if I want to write a book, my book is going to be made out of paragraphs. Each paragraph will have sentences in it. The sentences will have words and other punctuation to them. The individual pieces there, the words, which are basically the smallest thing that kind of has meaning to itself. The equivalent in a programming language is something we call a token. A token is an element that if you mess with it, you will alter what it means. Kind of like if you have words and you start sticking spaces in the middle of words, they're not the same words anymore. Same thing goes with tokens in programming languages. The simplest tokens in Scala are things called literals, and they can be just, for example, numbers. And here inside of what's called the read evaluate print loop, we can type in a particular literal, like 3. Now this literal is a token. It also happens to be an expression. Okay, so an expression, I think the best analogy in English is an expression is a phrase. An expression is something that has a value to it, and it also has a type to it. And in this case, when I enter in 3, it is evaluated, and the printout that comes next tells us the value, which it's not surprising to see is 3. And then also the type. 3 happens to be an int. That might also not be too surprising. After all, you should remember from math that 3 is an integer. And in Scala, we have in a formal sense a type that we refer to as int with a capital I, and the integers are often represented by this type int. For non-integral values, for example 3.5, that is also a literal, and it is a token. If I were to stick spaces in there, it would change the meaning of things. And the type here is double with a capital D. Double is the closest approximation that we have to a real number in the Scala language. As we'll see in a few videos, it is not actually a real number. And what can we do with these things? Well, we can take our individual tokens and we can combine them in various ways. And as you might expect, one of the ways that we combine them, for example, is adding values together, or doing more complex arithmetic. You can see from this example that Scala actually knows proper order of operation because it did the multiplication before it did the addition. Those were all with integers. What if we mix in a double? So 3.2 times 8, for example. Well, it's 25.6, which happens to be a double. But what if this had been 5? And then the result is 16. If one of the values is a double, it will actually convert the other one to a double and then do the math there. Okay, so whether you're doing addition, subtraction, multiplication, if you include a double, everything winds up becoming a double. What about other operations? Division, for example. Well, 18 divided by 3, 6. Sounds reasonable. It's what you're used to. 17 divided by 3, 5. That might not have been what you're expecting, but the problem here, or the issue, is that 17 and 3 are both integers. If I make one of them not an integer, then you get the answer that you might have been expecting, which was 5.666 repeating, roughly 5 2/3. But in integers, we cannot represent that value. So instead, it comes out as just the 5. Really what's going on here is we're going back to the division that you learned when you were first learning division, before you knew about the ability to express fractions or decimal numbers. At that point, if I said 17 divided by 3, you took the 17 and you grouped it into as many groups of 3 as you could. you found there were 5 groups of 3. But then there were 2 left over. When you first learned division, you learned about the quotient and the remainder, and then you immediately forgot those things as soon as you learned about fractions and decimal. Here we care about the quotient and the remainder. When you do division on integers, you get the quotient. You can get the remainder by using an operator called modulo. And so 17 modulo 3 is 2, because that is the remainder that we get when we have 17 divided by 3. So this gives you a brief introduction to some of the numerical types, the basic ones. By default, integers will be used if something doesn't have a decimal point or isn't using scientific notation. And if it has a decimal point or it uses scientific notation, it will be a double. And we can do math on these things, so you now have the ability to use Scala as a basic calculator. You should take some time, play around with that, see if there are any other things that behave in ways that you might not expect them to.